All right, so the basic thing here is you're looking at this equation. Sorry, you're going to have to hear my son in the background. You're looking at this equation, and you're seeing how it already ends up. So the first thing I would do is I would just look at the coefficients. So we have p and -3, and somehow that has to equal -9. So really all you're saying is what times -3 equals -9? Well, it has to be 3. And then you're looking at the exponents. So let's look at the exponents. Here you have y to the 4th, and here you have y to the m, and then here you know it ends up with y to the 6th. Well, when you're multiplying with the same base, because that's y to the 4th, y to something, so they have the same base, what we're really saying is y to the 4th times y to how many would equal y to the 6th. Well, let me kind of think about this one like this. You got y to the 4th times y to the m equals y to the 6th. So kind of a way to like visualize this is simply y to the 4th means y times y times y times y times y to some unknown amount equals y, 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 y. Because it's y to the 6, right? Because here's 4 y's, here's 6 y's. Well, all we're really saying here is how many more would we need to get to 6, right? So if I have 4, how many more do I need to get to 6? I need 2 more y's, right? So that's why the m has to be 2. That's it for this one. Okay, so this is one that students just really overthought. But the thing I want you to understand here is, see how there's a 6y minus 9 there and a 6y minus 9 there? These are exactly the same. So what if you just took out a 6y minus 9, put it out in front? Well, now that would be gone, that would be gone, and what would you have left? You'd have a y squared plus 4. And that's it. Sorry, my son's making funny noise. But that's it, because look, I mean, you factor the polynomial below as the product of 2 binomials. Here's 2 binomials, and they're being multiplied together, so that's a product. That's it. Okay, in this one, they want you to find out what c and d are, and they have c and d here. But they tell you that it's equal to x minus 3 squared. So let's just see what is x minus 3 squared. Now you should recognize that as a perfect square, and you should be able to expand that with the pattern of a perfect square. That's the whole point of this question, is checking to see, do you know what the pattern of a perfect square is? But even if you don't see the pattern, you could still use the box method. So let me show you the pattern. Remember, if we did a minus b squared, we said, oh, that's always just going to be a squared minus 2ab plus b squared. So if you had x minus 3 squared, that's just going to be x squared, that's going to be a minus, 3 squared is 9, that's going to be a plus, and then 2 times 3 is 6, and then times x. So that's what it's going to equal. But let's say you didn't memorize that pattern. So what? You could just do x minus 3 times x minus 3 in the box. That'd be x squared, negative 3x, positive 9. Well, that'd be x squared. Negative 3x and negative 3x makes negative 6x, and then plus 9. It doesn't matter. These are the same things, right? These are equal. So the whole point here is, let's take this picture. Let's zoom in. We know now, right? We know that this is going to be x squared minus 6x plus 9. Well, sweet, because if that's negative 6, then that's negative 6. And if that's 9, then d is 9. And that's how we got these answers. That's all there is to it. So you could use the box method and figure out what the c and the d are. That's all there is to it. Okay, I admit this is probably the trickiest question on the test, but it's really not that bad. One of the main things that you need to recognize is that she's already factored this thing by grouping. She's already started. My son's saying hi. She's already factored by grouping, which means she's already done the first step in grouping. And the first step in grouping is to find these 2 numbers. Well, those 2 numbers in grouping are the exact same thing as the 2 numbers you would get from the star method. Those are these numbers that you get from the star. So let's just recreate the star. Hi, you saying hi? So the star method, what you do is you do 3 times negative 55, because remember it's A times it's C. And 3 times negative 55, that's 3 times 50 is 150, 3 times 5 is 15, so that's going to be negative 165. And these two came from some b value. You don't know what it is. It doesn't matter, though, because we don't need that to finish this off. We already know that this is n and this is 5. And we already know this is 3 and this is 3. So all we have to do is recognize that the same thing, if you're doing it by grouping or by factoring, it's the same idea, is that these two numbers, n and 5, have to multiply up to the same thing as 3 and negative 55. That's how factoring by grouping works. That's also how the star method works. Don't these things multiply up to that? And didn't we get that number from doing A times C? So it doesn't really matter if you do star or grouping. It's the same thing. So basically what we're saying is that something times 5 equals negative 165. Well, couldn't we just divide this by 5 to figure out what n is? I don't have a calculator handy, but I could still do some good old-fashioned long division. So what times 5 equals 15? That would be negative 3. Negative 3 times 5 is negative 15. Subtract that. That's going to turn into a plus. That would be negative 1. Bring down the 5. Again, it's going to be 30. 3 times 5 is 15, but it's a negative. And then when you subtract it, it becomes 0. Okay, so it's 33. If you have a calculator, you could have done that. I just don't have one handy. All I did is do negative 165 divided by 5 to figure out what n is. And hey, look, the answer is negative 33. Okay, now let's figure out how we can finish this problem out. Well, we've done the star method lots of times, and so we see this does not reduce. It's 5 over 3. So we would write that as 3x plus 5. That's one of my factors. And look, that's what I got here for one of the factors. This one on the left does reduce. Negative 33 divided by 3 is negative 11. So you would write that as x minus 11. And look, that's the other factor here. That's how you do that. So it's really just understanding that factoring by grouping is really the same process as the star method, but that these two numbers, when you factor by grouping, are the two numbers that go here in the star. So you can either go back and watch the video on how to factor by grouping, and I think the 3.3 notes, no, I'm sorry, 2.3 notes, 2.2, 2.3, something like that. Or you could watch the method on the star method. I think it's the same notes, but either way, you could do it either way. All right, that's it for this one. Okay, on this one, so I'm a little confused on some of the things you did here. What I want to do is I want to first just focus on this top line, this whole top line, and I want you to notice that if you look really closely, that just says x value is less than or equal to 1. So that means I would not plug in anything greater than 1. Like I wouldn't plug in a 2, a 3, or a 4. So you did make a t-chart over here, but I was just kind of confused on how you picked your values, and they're kind of out of order. So let me show you how I would have done this t-chart. Here's my x, here's my y. Yeah, I want x values less than 1, so let's put a 1 there, and let's do some numbers less than 1, like a 0, like a negative 1, like a negative 2, negative 3, negative 4. I'm going to go all the way to negative 5. So if I did negative, okay, let me back up. So all I'm going to do now is I'm going to say these are all x values that go into the green equation, because these are all x values that are less than or equal to 1. But then I also have this equation, which is x values that are greater than 1. So now I'm going to also list off values. So I'll still start at 1. I'm going to do that number twice. But now I'm going to do values that are greater than 1. That should be enough. And so now these are values that are for the bottom equation. So I can see that you plugged in some numbers here. You kind of went backwards, but I'm not really clear which ones you plugged into which equation, right? So like, see this 4, 3, 2, 1? Those are all greater than 1, so those ones should have only been plugged into this bottom one, because that's when x is greater than 1. And then this negative 2, negative 3, negative 4, that should have only been plugged into this one. And I think you should have kept going, because you should recognize that that's an absolute value equation, so you should already know that that top equation should look like a V. It should look like a V, either a regular V or an upside down V. And this one, since it's negative, is going to be an upside down V. So let's start plugging in these numbers, and we'll see what we get. So remember, the green numbers go into the green equation. I'm not going to plug any of these green numbers into the yellow equation, because that wouldn't make sense. These are x values that are less than or equal to 1. So I'm going to just kind of do this in my head. If you get stuck or you're confused on how I do it, just go to a calculator. So let's just do it quickly here. Let's start with -5. If I was to plug in a -5, -5 plus 3 is -2. Take the opposite value, it's +2. Then take the negatives, -2. -2 and 4 makes +2. Let's go to -4. If I was to go to -4, -4 plus 3 makes -1. Then you take the opposite value, it becomes +1. Then you take the negative, it becomes -1 again. Then it becomes 3. Okay, let's plug in a -3. That one's easy. -3 and +3 makes 0. It doesn't matter if it's positive or negative, 0, so that becomes 4. Let's plug in a -2. -2 and 3 makes 1. Then it becomes -1. Then it becomes, then we add 4, so it becomes 3. Plug in a -1. -1 and 3 makes 2. But then you play the negative, it's still 2. I'm sorry, it's -2. -2 and 4 makes 2. Sorry, my son is distracted. Okay, let's plug in a 0. 0 plus 3 is 3. Then it becomes negatives. -3. -3 and 4 makes 1. 1. We're going to plug in a 1. 1 and 3 make 4. Make it a -4. -4 and +4 make 0. Okay, that was all the green numbers. So now, if I went to go graph these on your graph, -5, +2, well, that's right here. -4, 3, that's right here. -3, 4, that's right here. -2, 3, that's right here. -1, 2 is right here. 0, 1, you did get that point right. Okay, so we got that one, that's good. And then 1, 0 is right here. So I'm really confused where all these points came from, because if I plug these into the green equation, these are the points I get. And I can kind of tell what's happening here. I can kind of tell that I'm going to get an upside down v. But remember, this thing says only x values that are less than or equal to 1. So right there at 1, I'm done. I stop. I make a nice big solid circle because it's equal to 1. And I'm going to make my v. And my v is going to keep going like this. If I was to keep plugging in negative numbers, I'd keep going down this way. We don't need to do that. We have enough information to see what the v looks like. And you should know it's a v again because that's an absolute value. All right, now let's do the yellow numbers. Actually, I'm going to highlight this so we can see. See, this is the green side. Okay, now let's do the yellow numbers though. Again, I'm just going to plug these in kind of in my head. So I'm going to do a 1, a 2, a 3, and a 4. 1 times -3 is -3. -3 plus 4 is 1. 2 times -3 is -6. -6 and plus 4 is -2. 3 times -3 is -9. -9 and 4 is -5. Okay, I don't think 4 is, well, we'll do 4. 4 times -3 is -12. -12 and 4 is -8. So I get -8. All right. So now I can graph these points. So 1, 1. Here's the tricky part with this first number. Remember, on the bottom equation, it says x is greater than 1, not equal to. So I'm not going to put a solid dot there when x is 1. I'm going to do an open circle just at that first spot, right there at 1, 1. But then the rest of these points are normal points. So there's 2, -2. There's 3, -5, and then there's 4, -8. And so we can see that these points, my son's having a good time. We can see these points together make a line. Now let's go back and look at all this. See how this makes sense. So I'm going to highlight this side, because this is the yellow side. Let's see how this would make sense now. Okay, remember this is an absolute value function, and its vertex is at -3, 4. Let's look. Is it at -3, 4? We had a point at -3, 4, didn't we? And it was the vertex. Boom. Okay, perfect. Hey, look, that value out here is -1. That means the slope on the right side is -1. And sure enough, it goes down 1 over 1, down 1 over 1, down 1 over 1. That's the slope on the right side. So that does make sense. That fits our equation, right? And it ends when x is 1. It stops at x is 1, which is what it did right here. When x is 1, it stopped. Then let's go to the next equation. This is -3x plus 4. Well, that's just a y-intercept of 4 and a slope of -3. But remember, this one starts after 1. So, slope -3, y-intercept of 4. Well, definitely has a slope of -3. Look, it's going down 3 over 1, down 3 over 1, down 3 over 1. That makes sense. And it started when x is 1, but if it didn't start when x is 1, where would it end up? Well, look, wouldn't it have a y-intercept right here of 4, just like it says 4? And so that's the trick here, is that you can tell what these things look like because these are graphs that you should already know. All that's different really is that you have a specific starting point and specific ending point. And that's what this part over here on the right is. All right. And if that's still confusing, I encourage you to go back and watch the 2.2 or no 1.2 video, I believe, is the one that talks about graphing piecewise functions. But you need to be able to do that. You need to be able to tell what values go where. I hope that helps. See you on the next video.